So the topic we are discussing is HSRP. It is basically a redundancy protocol that provides the redundancy for the network path, devices, etc. So before discussing HSRP, let's take an example. Let's say I have two core switches. Okay. Let's say this is switch 1. This is I have switch 2, and I have an access switch also. Okay, from whereby systems are connected. So let's say this is PC1, this is PC2. For example, let's say this is PC3. I'm just taking an example just to discuss a scenario, and then we'll come to the topic HSRP, why we use HSRP, what is the use of HSRP, how it works, right? So let's say this is access switch. Okay, here my PCs are connected, and all of these PCs are in VLAN number 10. This is also VLAN 10. This is also VLAN 10. Now, I have two links going to the core switches from my access switch. So my access switch is connected to both the core switches. Okay. So let's say this is port number Ethernet 1/1. This is port Ethernet 1/2. And just to have the difference, let's say this is Ethernet 1/3, and this is Ethernet 1/4. Okay. Now the PCs are configured with the IP address. They are getting IP from DHCP, and all other things are in place. And for example, let me take example of a single PC with the IP details. So my PCs are having IP address as 10.10.10.x. They are having a /24 subnet from which they are getting the IP. So I am having 255.255.255.0, and default gateway. We'll come to this default gateway configuration, or what should be the default gateway, and what if the default gateway is switch 1, and what if the default gateway is switch 2. So now this is VLAN 10, and L3 of this VLAN is created on my core switches. These are my core switches. Okay, both of them. These are the L3 switches. So what configuration I am having, for I'm discussing about only VLAN 10 specific configuration. So let's say on switch 2, I have config 3 when I log into switch 2, and I go to, I have created a VLAN 10. I have named it as HR VLAN. So also now I'm creating a L3 of the VLAN. I'm creating L3 VLAN 10, and IP address for this one 10.10.10.2, because this is switch 2. It's a logical IP configuration. You can configure anything coming in this range. And then the subnet mask, as it is /24. So I'll put 255.255.255.0. Now, same configuration for the VLAN 10 is also on my switch 1. So I have config terminal. Then I have VLAN 10 name HR VLAN, and I have this L3 created here also for VLAN 10, interface VLAN 10, and IP address, I'll put it here, 10.10.10.1. Let's say /24, simple, keep it simple. So now let's discuss a scenario here. So on these PCs, if I put my gateway 10.10.10.1, okay, what will happen? So, and consider these all configuration are in place, like this is a trunk port, this is trunk port with VLAN allowed, VLAN 10 is allowed, and these are configured into VLAN 10. I'm just considering the topic Hsrp, just creating a scenario. So let's say we have a 10.10.10.1 configured as the gateway into my PCs for VLAN 10. And this gate, now these switches are further connected to a firewall, okay? And that firewall goes to the internet. Now what will happen? So my traffic will hit the access port here. It will, in search of the gateway, it will go as the gateway is .1. So it will search the .1 and it will reach switch 1 because .1 is configured in switch 1, and from switch 1 it will go to the internet. Everything is working on this PC. What if this switch 1 goes down? If my switch 1 goes down, now my gateway becomes unreachable for all the PCs. Here, for example, I have taken 3 PC, but it's a /24 subnet. Let's say we have 200 users. All will be impacted because they have the gateway .1, and .1 is unreachable now. So you will check and you found that the gateway where the gateway where it was configured was on switch 1, and switch 1 is not up now. So as a workaround, or as to fix the issue, you change the gateway on the PCs to .2. Where is .2? .2 is here on switch 2, .2. Now all the PCs having gateway .2 will work because .2 is still up, right? So what will happen? You know that like this ARP will be sent now when the PC will need to reach the .2, it will send a ARP request because it doesn't know the MAC address of the .2. So when the ARP goes through these access switch port, just in querying the MAC address of the IP.2. So when this switch will reply, oh, I own this IP.2, it will reply with its MAC address. And this switch will create a MAC address table where it mentioned switch to MAC address via interface Ethernet 1/1. Right? Same was happened for .1 also when they were searching for .1 MAC address. So switch 1 will reply for the ARP query, and this access switch will create a MAC address entry for .1 MAC address and towards Ethernet 1/2. Now, when the packet is going to .2, so it will be sent to this interface because MAC address of this .2 is learned on this switch via Ethernet 1/1. Now, what happens if this switch comes up again? Now your PCs are configured with .2, or this PC's in near future goes down. Now again, .2 is unreachable, or you want to make the scenario as it was before the issue, right? So what you will do, you will again have to change the gateway on the PCs, either via DHCP or manually based. It totally depends, but I'm not going to on the DHCP and other stuff. I'm just focusing on Hsrp. So to resolve this issue, what happens? We have this protocol, which is known as Hot Standby Router Protocol, Hsrp. What it will do, it will maintain the availability of the gateway IP or of the virtual IP. So how Hsrp will allow us to create a same virtual IP on both the devices, switch 1 and switch 2. Okay. So now let us put some commands one by one after discussing. So what will happen on the same VLAN, on the same L3 VLAN or the interface VLAN, you will configure the Hsrp. Now you will put standby, okay, a group number, because this is VLAN 10, so a logical name would be 10. Okay, so this is the standby and the group number. You can put it VLAN, you can put it is standby 100, 1, 10, 20, anything. But just to match the logical nomenclature, I have taken 10. So what you will configure is standby 10 IP address for this group. Okay, so IP address should be in the same range, .2. So let's say I have .1 on switch 1, .2 on switch 2, and let's say Hsrp IP would be .5. So I'll put standby 10 IP address 10.10.10.5. Let's say I have taken Hsrp IP5. The same standby group should match with the other switch, because this device should know that my standby group 10 has 2 members, for example. So in this scenario, so I'll configure the same thing here also. I'll put standby 10 because I have to match the group, then IP address, then 10.10.10.5. Okay. Now I have the same IP address, and on all the PCs gateway, I'll not put the gateway as .1 or .2. Rather, I'll put .5 as it is the virtual IP. Now, Hsrp help us to provide the redundancy by making one device as active, which will handle the traffic at a time, and another device is standby. So based on the priority, it will choose the active device. So higher priority device will become active device. So we have to define for standby 10 and priority, let's say 110. Why I have taken 110? Because 100 is the default priority. So if I even do not configure here the priority, so it will be by default 100, and higher will be for switch 1, as this is 110. So it will take the role of active member. What does active member in Hsrp group means is this will handle the traffic. It will reply to the ARP coming to the .5 IP. Okay. Now what happens when for this .5 gateway, my PC will do the ARP to reach the gateway. So switch will send the ARP entry broadcast to the all VLAN 10 interfaces. Now this switch will reply because this is the active based on the priority. But just to see like how we'll configure, you can make here standby 10, and you can also put priority here, but it should be less than 110. Okay. By default was 100. You could have put 100 also, but it's 90 just to make it a lower priority device. Which one? Switch to. So what will happen when the Hsrp hello message will be shared between these two devices? So the switch 1 will be elected as the active device based on the higher priority. So now coming to the point, when these PC will send the ARP to check the .5, so Hsrp has the virtual IP along with the associated virtual MAC address. So let's say the MAC address for this .5 IP here, I'll put here 10. Let's say this standby IP 10.10.10.5, and let's say my VMAC is v dot v, for example. Okay. So now this will switch 1 will reply based on the priority to the ARP of .5. So when the ARP will be sent from PCs, so what they will mention, let's say the IP of this PC1 is 10. So it will be something like source IP would be 10.10.10.10. Destination IP would be 10.10.10.5 source MAC, let's say PC1, 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 and DST MAC is unknown. Okay, this is expected in the reply of ARP. So what will happen when this ARP request will go from VLAN 10? This switch, access switch, will make a ARP table or MAC table entry. Okay. How it will make? It will put into the table that because it received the ARP from interface. Let's say this is interface 1/10. So it will make an entry. Let's say it will mention interface and the MAC. So it will mention interface as 1.10. Now which MAC it will put here? Because it is receiving MAC this from interface 1.10. Why? Because this packet R will go into the switch via this interface. So it will make entry here as PC1, PC1, PC1. So now switch knows like PC1, PC1, PC1 is MAC connected to 1.10. Okay, not every time it need to send the ARP or need to wait for the ARP reply to update the MAC address table. It know already, right? Until the table session timer expires. Now, when the replies come, so who will reply to the .5 ARP entry? This MAC address, switch 1. So switch 1 will reply, and the reply would be here it will be filled instead of question mark. Let's say I have put the VMAC here as v.v.v. Let's say it reply with v.v.v. So now this reply to this interface of access switch. So access switch make another entry where it will mention Ethernet 1/2 as the interface. I'm not putting ETH here. And the MAC address would be v. Okay. So now, it received this. It received the request. Now this PC will receive the ARP reply, and this will also update into its internal table. And when anything is going to .5, so the MAC address is v.v.v, and access switch know how to reach v.v.v via Ethernet 2. It will send all the traffic to switch 1, and from switch 1, where the respective destination are destined or routed, it will go. Okay. Now consider the previous example. Let's say this device goes down. Okay. What will happen now? Earlier, we had changed the gateway, but now the gateway .5 is on switch 1 also, is on switch 2 also. But earlier, because this was up and active based on the priority, it was replying to the ARP addresses. That's why this access switch has updated the MAC address table. Now what will happen? Based on the hello timer, hello time interval limit, it will know that, oh, I'm not getting reply. I'm not getting my hello packet reply from my other Hsrp group 10 member. So let me take the responsibility. I think there is some issue or it is down. So now this switch 2 with this MAC address, because this combination remains same on both the switches based on the Hsrp configuration. This is the work of Hsrp. So this is how Hsrp works. So what switch 2 will do? Now these will not send the ARP again. PCs will not send the ARP again. So how this will be updated then? How this will be updated? Because the device connected via Ethernet 1/2 is down. Switch 2 will send gracious ARP. You might have heard of gracious ARP, GR. Okay. Now it is a special type of ARP. What happens here? Now switch 2 will send source IP 10.10.10.5 source MAC v destination IP 10.10.10.10 destination MAC. What does this mean? Switch 2 is waiting just to check, like, will anyone reply to this? Anyone into my known broadcast domain of VLAN 10 owns this IP, just to check the IP duplicacy or whatever. So now, as soon so and like in ARP normal ARP request, ARP reply is expected. In gracious ARP or GARP request, we do not expect any reply, because if it comes with any reply of a MAC address here, it means that I am also owning this IP. My MAC is this, and someone else is also owning this IP. So this could create a problem. So no reply is expected, just to update the switch MAC address table. How it will be done now? So now this will send this gracious ARP to the downstream devices, which is access switch here. So as soon as access switch received the gracious ARP on Ethernet 1/1, it will check what information I could update onto my MAC address table. It will see, okay, I have v.v.v, but I'm receiving this from Ethernet 1/1. Oh, I was getting it earlier from 1/2. Maybe there is an update. So let me update this one. So it will update this to 1/1. Okay, let me do it again. It will make the interface as 1/1 here. See, this is now updated. So now what will happen? PCs are all the downstream devices are unknown what happened above. Okay. So now now what happens is now they are going again v.v.v, but this switch is not sending towards 1.2 because now the MAC address has been updated. It is not 1.1.2, it is 1.1/1. So it will again go here and whatever was working will work. So this is how redundancy is created. This is how availability is ensured. Okay. So this is the configuration of Hsrp. This is the working of Hsrp. Now let's take a further example. Now let's say this device comes up again. This is up again. What will happen? This is up again. When it comes up, it will recognize itself as, it will recognize its VLAN 10 as a part of Hsrp group 10 member. It will send the hello packet information being shared and all of things. So it will detect another member which is working or acting as an active member as of now. It will not do anything. It will see, okay, we are two. My peer is active now. Let me sit. I should not interfere. I should not disrupt the traffic. So it will sit like this only. But now both the members are up. Now you want to know, or you want to do basically the scenario or the exact scenario what was before the issue. It should be achieved, right? So we could not, when we was working on switch 1, why we are working on switch 2 when switch 1 is up again. So, and why switch 1 is not participating into the election again, it is just because it do not want to disturb, it do not want to disrupt the traffic. Now here comes a magical command of Hsrp, which means, which says standby, again because I am doing the changes on group 10, and the command is primp. Now, as soon as you put primp, now what primp do? What primp do is, primp make the higher priority device active forcefully, even if there is existing a active device running. So when in the hello packet messages information is shared, it will see, oh, my priority is 110 and my peer priority is 90. So primp will take this role. What primp will do for this standby group 10, make the higher priority device active again. This is known as preemptive action. Okay. So what primp do is, primp make the higher priority device active again. So when primp was not configured, switch 1 came up, switch 1 is up, 2 members in standby group 10, nothing happening. Switch 2 is taking the lead of the traffic, no gracious ARP. Now as soon as it take the responsibility of, now we configured primp, preemptive action happen. What primp will do? Make this device again active. Why active again? Because the priority of this device is 110, this is 90. Based on the priority selection, it will be primary device. So now, as this is now the primary device, it will again send the gracious ARP because the downstream devices are unknown of the activity happening above. So it will again send the gracious ARP. Now gracious ARP will come to the switch. Switch will know, okay, I am getting this ARP for v.v.v.v. Oh, I have this for 1/1, but this time I am receiving it from 1/2. Let me update this. It will make it 1/2, and everything start going from here to here and here. So this is HSRP. What HSRP do? HSRP provide us the redundancy. I have created on VLAN gateway basis. You can also it can also be applied to, for example, this is the firewall. This is some, let's say, some device, network device. These are my router. Okay, router. These are the physical interfaces 1/1 and 1/2. I have IP here 1.1.1.1. I have IP here 1.1.1.2. You have a default route on this device, let's say IP route. So there are n number of used cases. So I have a default route here, for example, IP route 0.0.0.0.0, 0.0.0.0.0, and this route is towards physical IP of the interface. Let's say this is as of now towards 1.1.1.1. So all the traffic will go towards this following the default route. And as soon as this goes down, everything becomes unreachable because next hop is unreachable, which was on this device, and this device is down. You have to make a route entry, update the route, and you have to put a route, IP route 0.0.0.0.0, 0.0.0.0.0, and you have to put the next hop as .2, right? Why 2? Because this is up and you have to you need to reach to this to have the further connectivity. So now again, when this comes up, you will do the changes. So better create HSRP IP into the interface configuration like we did for interface VLAN 10 here. Here, go into the interface 1/2 where you have put IP address 1.1.1.1. Just put standby 10 or standby 1, whatever you wish. IP address from the same subnet 1.1.1.x. In here also, make the priority based on the requirement, like which device you want to make active, and put primed. Everything will work, and this default route should be towards the HSRP IP, not towards the physical interface IP here. So any one member, until and unless is up within the HSRP group, this will maintain the availability based on the HSRP working, based on its feature. Okay, thank you so much.